All right, so when we graphed, we picked values that we could take the square root of. Okay, so what I'm going to do for the first, we're going to write the first 15 perfect squares. So basically what I'm doing, I'm calculating on a calculator or in my head. 1 squared is 1, 2 squared is 4, 3 squared is 9, and you just keep working your way through all of the numbers. So you guys can find all of these numbers. 6 squared is 36, 7 squared is 49, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared. Now, those keep going because you can find 16 squared and 17 and 18, and there's infinitely many perfect squares, okay, because we can just keep going and going and going. Okay. So how we're going to use this is we're going to simplify square roots today. Okay, so product property of radicals is if I have the square root of a times b, I can split it up into the square root of a times the square root of b. So you split up all of your pieces. So what I do is I always split up my numbers and my variables. Okay. So for instance, this first one becomes square root of 4 times square root of x. Well, square root of 4 is 2. Now, square root of x doesn't simplify, so we just leave it as x. Next one, same thing. So square root of 49, square root of x squared. So square root of 49 is 7. And then if you remember from last chapter, square root of x squared is x. Okay, so basically what we do is we divide that exponent by 2, as long as it's an even exponent. Okay, this property also works backwards. If I'm multiplying two radicals, I can multiply them together and say it's the square root of 12 times 3, which is the square root of 36, which we can simplify as 6. Okay, so that's the product property of radicals. Okay, so before we do these slides, what I want you to understand, so square root of x was just square root of x. Square root of x squared, we got x. If I have square root of x cubed, okay, that's not divisible by 2, but I can break that apart using that product property here into the square root of x squared times the square root of x. Well, if we use our two rules from above, that's x times the square root of x. So if I have something like the square root of x to the 20th, okay, I don't really want to write that out 20 times. So you actually get, remember that rule that I told you, divide your exponent by 2 is x to the 10th. Okay, so we always want to use even exponents if we can. Okay. So that'll help us on this slide here. So square root of 48. So 48 is not a perfect square. So what you're going to do is you're going to break it down into something times something. So think a perfect square that goes into 48. Most of you would think is 4. So you got 4 and 12. So square root of 4 is 2. And then we got square root of 12. To make sure that you have the correct answer, is there a perfect square that goes into 12? Actually, yes, there is. You break it into square root of 4 times the square root of 3. Well, this is also 2. So you have 2 times square root of 3. Multiply your two 2's, you get 4 square roots of 3. Okay. Next one, break it apart. So square root of 25. Now remember what I told you, this is not an even power, so we're going to break it apart a little bit. So we're going to have an x and then x to the 4th. So we know this is a 1. 1 plus 4 is 5. So then you get 5 x squared square root of x. Bottom one goes the opposite way. So square root of 7 times square root of 7 is square root of 49, which actually is 7. All right, last one. Make that a little bit harder. So square root of 289. So guys, that's a really big number. Not on my list, but it's actually bigger than the numbers on my list. So what I want you to do is always type it into your calculator first. So square root of 289 is actually 17. Okay, so it's a perfect square. We just didn't have it on our list because we didn't keep going. Square root of a to the 20th is a to the 10th. Square root of b to the 4th is b squared. Square root of c to the 12th is c to the 6th. Then this last one, so we're going to take negative 5 times the 1 that's really in front of that, so you get negative 5. And then we're going to multiply our square roots, so square root of 40. So find a perfect square that goes into 40. So we get negative 5 times the square root of 4 times the square root of 10. So negative 5 times 2 times the square root of 10. And negative 5 times 2 is negative 10. Okay, so that is simplifying square roots. Okay, we want to be able to do this as one of our pieces as we're making up our puzzle of chapter 11.